Welcome. In this lesson, we're going to basically be using what's called the change of base formula in order to evaluate or solve exponential equations that would be otherwise impossible without logarithms, because I have no clue what exponent I need to put on 8 in order to get it to equal 3. So what we do is we're going to use, for this lesson, they want us to use the common log. We're going to take the log of both sides. Log of 3 equals the log of 8 to the x. As long as we do the same operation to both sides, it will remain equal. Now I'm going to use my properties of logarithms and bring this x, that's an exponent on the 8, out in front of the logarithm of 8. So I have a common log of 3 equals x times the common log of 8. I divide over the common log of 8 to get x by itself. So now you use a calculator. So if you need to refresh yourself on how to do that, do so, or come ask me how to operate your calculator. But you're going to take the common log of 3 and get a number, and then you're going to divide it by the common log of 8. And then you just get 0.528. So again, it's kind of doing a change of base formula. Again, I followed the same process here. I took the common log of both sides of this equation. That one enables me to bring the x out in front of the log base 5, which then I can divide by that log base 5 in order to get x by itself. So I have common log 4 divided by common log of 5. I do this on a calculator, and I get 0.861 because it says round to the nearest thousandth. Again, we're going to do the same thing here, except now we're going to have one additional step. And that one additional step is just that I'm going to be dividing by a 3 log of 9 rather than just a log of 9. Be careful as you walk through this. Again, I took the common log of both sides of the expression, common log of 9 raised to the 3x, common log of 2, brought that exponent of 3x out in front, so that's a 3x, not 3 times log. That's a 3x log 9. And then I divided by the log of 9 and the 3 and the log of 9, leaving that x. And I get 0.105. Again, I'm going to kind of jump ahead. Well, here's an addition one. Maybe I'll do this one as well. The reason I thought I should do this one as well is I need you to make sure you remember this x plus 1 is a single exponent on the 8. So when I take the common log of both sides and I bring that exponent in front, I need to keep it in parentheses. It's x plus 1 times the log of 8. So I'm going to divide by the log of 8, this log of 7, by the log of 8 first, and then minus the 1. So you just got to follow order of operations and be careful with your equations as you solve them. I'm going to start jumping ahead until I find one that I think that I haven't really kind of talked about. Like this one, I think you need to realize that you need to minus the 3 over first. Don't just automatically take the log of both sides. Get it down to a single term raised to an exponent and a single term raised to an exponent. But if you were smart and you realized, hey, what would you get to, how would you get to be an exponent of 1 with an exponent? Well, it has to be 0. And 4 times what is 0? It's 0. Or you could actually take the time to solve through this and realize that log base 10 of 1 is 0. 4 times the log of 7 is some number. 0 over some number, 0. And anyway, this one has an answer of 0, or x must be 0. I just wanted to make sure you realize that I had to add the 1 over first. Add the 1 over first, and then do those common logs. Yep, I don't see anything harder in this lesson. Just add the 1 over first, take the common log of both sides, and reduce your expression until you can solve for x. If you have any questions, please bring them to class.